Hello, this is going to be for review number 15. I'm Mr. Lakin. This is going to be your last, this is going to be my last video for you. I'm going to be going over problems number 1 through 22 in this video. So number 1, a balloon is currently 30 feet off the ground. There's a little girl that let go of the balloon, notices that the balloon falls at a rate of 6 feet per second, so obviously this is a very astute little girl. We're going to write a linear equation to model the situation. Okay. So there is a balloon that is 30 feet off the ground. So there's 30 feet off the ground. And it's falling at a rate of 6 feet per second. Which means we have a negative value here. Okay, to write a linear equation of it, we're going to need this form, y equals mx plus b. M is going to be your, M is going to be your rate, and B is going to be that starting value, that initial height. So if we plug everything in, we get y is equal to negative 6x, and then it's going to be plus 30 feet off the ground. Okay, and there's your answer. Your teacher may ask you, x is going to be the x is seconds, and y is height. Height of balloon. We didn't put this in the answer key, but it is a good idea to still know what you're talking about, what x and y actually are. Number 2, write an equation of a line that has an undefined slope and has an x-intercept of 3. Let's draw a picture. So, x-intercept of 3 would be something like, here's 3. Now, an undefined slope is a vertical slope. So that's a vertical slope, and vertical is up and down. So the line should look something like this. It's a horrible line, Mr. Lakin. So our answer here will be x equals 3. When you have a vertical line, it will always be x equals whatever number. And on that matter, if it's at a 0 slope, so a separate problem, if the problem said a 0 slope, you would do y equals just a number. Number 3. Okay, let's solve it. So I'm going to start with the left-hand side. I'm going to distribute this negative 3, so I get negative 3 times 4, which is negative 12x. I get negative 3 times 5, which is going to be a negative 15. The plus 3x isn't changing. I'm just going to clean up this side before I go to the other side. I can do a negative 12x and a 3x, which gives me a negative, let's say negative 12 plus 3. That's a negative 9x. And then it's a minus 15. And then equals. Okay, now let's work on the right side. The 12 stays. The negative 5 gets distributed. So I have negative 5x. And I have negative 5 times negative 4. That's going to be a positive 20 and a plus 7x. And I'm going to have to combine like terms here. So I have to do 7x minus 5x, or negative 5x plus 7x. It's going to be 2x. And then I also have to do 12 plus 20. It's going to be 32. And now I'm going to go and move numbers on one side and variables on the other. So I can go ahead, and it doesn't matter which way I do this. I'll just rewrite this all in black again so I can reuse the colors. Okay, let's go ahead and add 9x. If you didn't want to do that, that's fine. I'm also going to go ahead and subtract off 32. And again, I'm trying to get everything on one side of the equation. And those 9x's are gone, these 32's are 0, and I end up getting out. Going back to blank again, negative 15 minus 32. I can check this on the calculator, I get negative 47. And this is going to be 11x. So divide by 11 because we're multiplying by 11. Get x equals negative 47 over 11, which is going to be kind of an ugly answer. We would be looking for an exact form. There would be no decimals allowed here. Number 4. Okay, to graph the line here. So this is a slope-intercept form. Our slope is negative 4 over 5. And what I've been telling my kids, and I think you've been hearing it from your teacher as well, if you have Mrs. Locust, is a negative 4, when you have slope, you have a choice of going up or down, and usually to the right. Usually. The up will be if you have a positive value. The down will be if you have a negative value. So, in this example, I have a negative 4 on top for my slope. And again, this is my slope, the number before the x. And that means I'm going to be going down 4. So, down 4. And to the right 5. Okay, now that's part of it. I need a starting value, an initial height. And my initial height is going to be right here. This is going to be my y-intercept. Okay, and if these words are too fancy for you, all that means is the plus 5 go on the y-axis, not the x-axis, the y-axis. So on the y-axis, 1, 2, 3, 4, 5. So I'm going to start off my graph right here. And then as I said, I'm going to go down 4 from that initial value. 1, 2, 3, 4. So I went down 4. And now I'm going to go to the right 5. 1, 2, 3, 4, 5. Okay. And then I can make a line between those 2 points. Let's just make a line. I'm just going to change it to make it look a little bit more exact. A student once laughed at me in class because I couldn't do this even with a computer-generated tool. It's pretty embarrassing, but there's the line. Okay, so that should be your answer. Notice again, if you go down another 4, because this is kind of important to know, if you go down another 4, 1, 2, 3, 4, and you go over 5, you end up kind of crossing through another point. Also notice one other thing. You could go up 4, because someone's going to say, well, how come you can't go up 4? And that's true. You could do this. You could put the negative on the bottom. And now that the 4 is positive, you would go up 4. But you would also go to the left 5. Because remember, the 4's are for the y's. So the top number is for the y's. The bottom number are for the x's. So you could have a positive 4 and go up 4 and to the left 5. So let's see what that looks like. And this should have been in purple, so to the left 5. So for up 4, from this point, 1, 2, 3, 4. And then to the left 5, we could have another point there. So you don't always have to go to the right. It just matters on which side of the fraction you put your negative on. And it's not wrong. You just have to choose which side of the fraction to put your negative on. And I hope I didn't confuse you any more than that, but that's what your picture should look like. And that's how you should do the problem. Number 5, y equals negative 3. Now that's tricky. There's no slope. So no slope means horizontal line. And if you didn't know that, you could go to y equals negative 3. And y can only equal negative 3 for any x value. So like x equals 5, y has to be negative 3. X equals negative 9, y has to be negative 3. And you can keep doing that all along the x-axis. X equals 3.14, y equals negative 3. And what that means again is that we're just going to have this line here that's nice and horizontal. And that's your answer. And it's going to go through y equals negative 3. Okay, to solve the following system equations. So to solve system equations, you can use substitution or elimination. Now you could also do by graphing, but I don't think we're going to be testing you on that. The reason we're not going to test you on that, in case you're curious, is because graphing is not exactly that accurate. Now, if you want to use substitution, it's not a hard and fast rule, but if you want to use substitution, a variable should already be solved for. If you want elimination, again, not a hard and fast rule, but elimination, usually variables will be on both sides of the equation. I'm sorry, variables will be on, all variables will be on one side of the equation. Okay, so I looked at this problem here, number 6, and I see that I have one variable, y equals something, which means the variable is all by itself, so I should probably try substitution. And the way that works is I take this little part, to negative 3x plus 4, and I'm going to go ahead and plug that in to the y in this equation. So I'm going to get 2x plus 3, in the big parentheses, I'm going to plug that in now, negative 3x plus 4. I'm going to close parentheses, I'll write the rest of the equation, equals 5. And now I have this new equation to solve for. So I get 2x plus, now let's distribute. That's going to be 3 times negative 3, which is negative 9x. I got 3 times 4, that's going to be a positive 12. And equals 5. Okay. It looks like I got some like terms I can combine here. 2x minus 7, 9x. That's going to be negative 7x. And then I'll go and subtract 12 from both sides. And I get negative 7x equals negative 7. And we would divide both sides by negative 7. Since we're multiplying, we'll divide by negative 7. We get x equals 1. Now you're not done yet. Once you have x equals 1, you have to plug 1 back into the original. You can plug 1 into the right equation or the beginning equation. When I do substitution, I usually plug 1 into the equation where y is all by itself because it's easier. So I'm going to do that. Y equals negative 3 times 1 plus 4. And I get negative 3 plus 4, which gives me 1. Now, I've had many of my students leave the answer like this. They've missed a point each time if they've done it, because your solution to a system of equations is not only two numbers, but it should be in a coordinate pair with an x and a y. And make sure you put in parentheses. So 1, 1 is your final answer. Okay, number 7. This is a weird one. Mr. Foster and Mr. Lake went to a local gas station. Foster bought some number of Slim Jims at 1:30. Lakin bought several chips for 6. When they went to the cashier, total was $22.25, and they left the store with a total of 108 items. Okay, so let's get some variables here. We'll say Slim Jims at 1:30 will be, I'll use what Patrick did in class. We'll call that SJ. SJ will be number of Slim Jims. And we'll go and say that and chickens. We'll call that C. And chickens is C stands for the number of chickens. So now let's make an equation here. Each Slim Jim costs $1.30, and that wasn't clear in the question, but that is what was intended. Each Slim Jim costs $1.30, so we'll say 1.30 SJ plus each chicken costs $6, so 6C, and that's supposed to equal, now how much did this cost of all this equal? There, $2.25. It's a lot of money at a gas station. Now when they left the store, they left with a number of items as well. So there were two variables here. How much, there were two situations. How much everything cost and how much they actually got. So that second part is, it looks like the number of Slim Jims plus the number of chickens equals 108. And there's my setup. And once I have my setup, then I'm home free and I can actually start solving this. So let me rewrite this part in black now. That's not black, but whatever. And then we can go ahead and solve for either of these. In the last problem, I said elimination, all variables are on one side of the equation. And I notice here that in my purple equation, all variables are on one side of the equation. They're all on the left side. So I'm going to use elimination here. Don't mind me, I'm just erasing things here that had no bearing to the problem. Okay. So my next move, I need to eliminate. One thing I'm going to do here that might help me out, I'm going to put a 1 in front of the SJ and a 1 in front of the C, just to know what to multiply when I change these variables. I'm going to multiply both sides of the bottom equation by -6, because I'm going to cancel out the chickens. So -6 times 1 will be -6 SJ. -6 times 1 will be -6 C. And -6 times 108, I'll need my calculator for this, and make sure you have your calculator as well. Should be -648. Okay. I'm going to bring down the top equation, because that didn't change at all. 1.3 SJ plus 6C equals 225. Okay. And then I just add everything up vertically. I notice the chickens are gone. So now I have, and again, I'm doing this on the calculator, so make sure you do it as well. This is -423 equals, this is going to be -4.7 SJ. And when I do 423 divided by 4.7, which is my next step, I end up getting 90. If you weren't sure why I divided here, 4.7 was multiplying the number of Slim Jims, so I had to divide by it. I did the opposite of the multiplication. So SJ is equal to 90. The number of Slim Jims is equal to 90. So 90 Slim Jims. That's a lot of Slim Jims. And then I still need to find the number of chickens. I know that my total equals the total number of items that I left with was 108. So if I have 90 Slim Jims, I can do 108 minus 90, and that's going to give me 18. So I left with 18 chickens. And that's not the only way I could have found 18, but that's the way I chose to do it here. Number 8. Okay, number 8 through the rest of these are going to be laws of exponents, so let's go on and try these. big mistake that's commonly made here is this negative here. So I'll show you each step here. When there's a power to a power, I got to do -3 in parentheses to the fourth. I got to do x squared to the fourth, which is going to be times 4. And I have a times x to the third just waiting here. This I'm going to use a calculator for, and I'm going to make sure I put parentheses. Please, for the love of all things that are necessary in life, put the parentheses, and you end up getting out 81, a positive 81, times, this is going to be x to the 8th, 8, not 6, Mr. Lakin, that's an 8, and then times x to the third, and then this last step, when I multiply the same variables, I add the exponents, so I get 81 times x to the 11th, and again, that came from the 8 plus 3. So my final answer, 81x to the 11th. Number 9. So there's a long way of doing it. You can distribute the 0 to each one and find out that each one of it is equal to, that all of this is equal to 1. The shortcut, when you have anything raised to a 0 power, it equals 1. So this problem simplifies to 8 times, and again, anything to the 0 power is 1. This is just 8. And again, this simplicity comes from anything raised to the 0 power is 1. And mathematically, that's not entirely true, but for this class, we're not going to try to trick you with this. For your purpose, anything to the 0 power is 1. Okay, this one. So same property that you applied in the last two problems. This is a power raised to a power. I am going to put a b to the first here, just because I want to make sure I have an exponent. So I'm going to do a to the 2 times 2, because when I have a power to a power, I multiply the exponents. And then times b to the 1 times -2. Okay, that's going to be equal to a to the 4th times b to the -2. Now I invite you to read the instructions here. Not only does it say simplify the problems, but it says rewrite using positive exponents. Some of my students have been changing those final answers to positive exponents, so be aware of that. No decimals. We don't have any decimals here, so we're good there. And by the way, there were no decimals in either of the problems before, so we didn't violate those rules. We also didn't have any negative exponents. Here we have a negative exponent though, so let's fix it. Negative exponents, we send it to the basement, and change the sign. So b squared is my new value for b. A to the 4th is going to be the numerator, and that will be my final answer. There's nothing else you can do there. In number 11, so we don't usually like to have negative exponents in the bottom. And again, the instructions say only positive exponents. So we send it to the top. And we change the exponent sign. So if you want to do x to the 3rd over 1, or just x to the 3rd, either answer would be fine. Please keep in mind this is a formula that when you have x to the -a, it's 1 over x to the a, or if you have 1 over x to the -a, it's x to the a. And this is going to be on your formula sheet. Number 12, this is again another one of those properties. Whoever made this review, Mr. Lycan, did not do a very good job with variety here. But we have, I'm going to put a little 1 here because that's important. So the 1 times 2. I'm going to, so this is all power to a power again. 3 times 2 and times y to the 7 times 2. And we end up getting out 4 squared times x to the 6 times y to the 14th, which is going to be 16 x to the 6 y to the 14th. We only have positive exponents. There are no decimals. and we can't simplify anything. That's our answer. Wow, these are so unoriginal. Another power to a power. Cool. I am going to put the 1 here, and I end up getting out 4 to the 1 times -2, and then times x to the -8 times -2, and then times y to the 3 times -2. I end up getting out 4 to the -2, x to the positive 16, and y to the -6. And again, only negative exponents. Move to other side of fraction. Which means those two have negative exponents, so we have to move them. The x to the 16th is going to stay on top, but those two are going to the bottom. So 4 to the -2 is now 4 squared. Y to the -6 is now y to the positive 6. And we can clean this up here. 4 squared is 16. So 16 y to the 6. And that's your final answer. Only positive exponents, no decimals. Number 14. So in my class I tell numbers with numbers, so I look at 27 over 36 first. I see that I can take a GCF out of 3 and 9. 9 is a better GCF. I get 3 over 4. So then the next thing I do, I prepare my final answer down here. I'm going to throw stuff on top and bottom. And I dealt with the numbers first. So again, I dealt with numbers first. Now I'm going to deal with variables next. Okay, variables next. So let's take x to the 12th over x to the 9th. Two ways you can look at it. One way you can see that the top part has 12 x's, the bottom part has 9 x's, so you're left with 3 x's on top. Another way of doing it is you could apply that property of x to the 12 minus 9, which is x to the 3rd. And that is on top because it is a positive exponent. For the y's, a couple ways you could look at it. You could do y to the 17th over y to the 18th and see that there's one more y on bottom than on top. Or you could go out and apply that property with y to the 17th minus 18. Because when you divide the same base, you subtract the exponents. So that's the same property in the blue that I may not have described that way. When you subtract 17 minus 18, you get -1. But we are only allowed positive exponents. That's the rule. So we have to send that one to the bottom, which is y to the first. Whoa! That is crazy town. Which is y to the first. So final answer. If you put the to the first power or not, that's fine. Number 15. Okay, again, numbers with numbers, so I'm going to deal with 15 over 18 over 48 first. I think I could take out a 3. And again, you should have a calculator. I'll set up my answer down here. So there's a 5 on top, 16 on bottom. Oh, negatives, that's not fun. So x to the -3 over x to the -5 is x to the -3 minus -5. Because when I divide the bases, I subtract the exponents. And if I'm not sure what that is off the top of my head, I can use a calculator. But it should be x squared. And again, notice there's a positive exponent in the top. So we'll keep that as a positive exponent in the top. Y to the 0 is just 1. So that's just 1. And that y to the -1 is coming up. So y the first. No math there to really do. Please note that z in the bottom has a z to the first. So let's just do that one. Z to the fifth over z to the first. There's more z's in top than a bottom by exactly 4. So I'm going to have z to the fourth on the top. Again, they're not in the bottom because there are not more z's in the bottom. There are more z's in top. So my final answer, 5x squared y z to the fourth over 16. Number 16. Oh, these are fun. Okay. Remember I said anything to the 0 power equals 1. And this does sound like a trick, and all I mean for it is anything in the parentheses to a 0 power has 1. Or you can have a number to the 0 power equals 1. If you have a letter like x times 5 to the 0 power, well, this part is just 1, which means your answer may not always be 1. So you have to be careful. This was a very long way of saying be careful. You're right if you're thinking that something to the 0 power is 1. Let's take a look. This term is 1. Everything is in the parentheses. That value is a 1, positive 1. This x to the 0 is 1. But the 4 is multiplying it, so this is 4 times 1. Minus this y to the 0 is a 1. The 3 is multiplying it, so it's 3 times 1. And then you do that math. 4 times 1 is 4, minus 3 plus 1, I get 2. If you go too fast through these, you'll miss an easy point. So be careful. Okay. Scientific notation requires us to put a number. So a number times 10 to a number. That's how scientific notation works. So we usually have to move the decimal place. I'm moving the decimal place here to the left, because again I can only have one number here, and that number will now be, so I move it 1, 2, 3. Okay, so I moved 1.0236. I moved this 3 decimal places, 1, 2, 3. So times 10 to the third. The way you can check your answer, because I've had some students say, how do you know if your answer is correct? The positive 3 here means that you have to move the decimal places 3 spaces to the right, because of positive 3. So if I do that, I should get the answer that I originally had, and I get 1, 2, 3. So let me just do this down here, just checking answers in case we're not sure. 1, 2, 3. So now I get 1023.6, which is what I had. Okay, number 18. Again, this should be a number. Oh, sorry. This is actually enough for this problem. So to go for standard form, 10 to the negative fifth, well, a negative 5 is in the negative direction, so I need to go back 5 spaces, so the 2.8 is going to go back 1, 2, 3, 4, 5. So that's the new decimal plate. Here's a 0. I'm just going to put zeros everywhere that I don't have one. So 0, 0, 0, 0. So my final answer, 0.000028. Okay. Number 19. These look confusing at first. What you want to do, maybe they look confusing, maybe they don't. What you want to do, I always try to keep these numbers together, and then I try to keep these numbers together. So 1.5 times 62 is something that should be done in the calculator, which I believe is 93. I have to double check that though. Yeah, 93. Okay, good. And then times, now 10 squared times 10 to the 5th. Well, we did that before. Multiplying bases, you add the exponents. So that's going to be 10 to the 7th. Now, scientific notation, though, so remember, our answers need to be in scientific notation. That means that we need to keep a number times 10 to a number. So I have 93. I don't have 9 point anything. So my decimal place is starting here. I just need to move 1 here. So I get 9.3 times 10 to the 8th. And if you weren't sure about that, I could show an intermediate step here. What I did first was I did 93 is 9.3 times 10 to the 1st. Because again, if I take that positive 1 and I move it in the positive direction, I get back that number again. And the 10 to the 1st and the 10 to the 7th equals 10 to the 8th, because I add the exponents. Number 20. Same idea here. I'm going to divide 1.75 and 2.5. I'm also going to do, on a separate side, 10 to the negative 3 over 10 to the 5th. Now 1.75 over 2.5, I believe, is going to be 0.7. 10 to the negative 3 over 10 to 5, well, I can subtract those, because when I divide the same bases, I subtract the exponents. Okay, so that's 10 to the negative 8. So I get 0.7 times 10 to the negative 8. Now, this looks good and all, but this number is not usually supposed to be a 0. It's supposed to be a number bigger than 0. So let's move this decimal place 1. And it's going to be 7.0 times 10. Let's do some side work here. 7.0 times 10 to the negative 1 is equal to 0.7. Let's check to see if that's true. If I take that negative 1 and I go back 1 space, I do get 0.7, so that's good. So I get 7.0 times 10 to the negative 1, but then times 10 to the negative 8, which is going to be 7.0 times 10 to the negative 9. For these two problems, 19 and 20, I've also seen students just list out all the zeros and then find the right decimal place. That's fine. I would recommend finding those shortcuts though too. That way you don't always have to do all that long work. But if you do the long way though and list out all the zeros, you'll get the right answer anyway. Alright, 21. So you'll need a powerful book for this. And on the back of our formula sheet, you're going to have all those numbers. If you have the booklet, you can go and take a look at 64. You'll notice that 64 has 2 times 2 times 2 times 2 times 2 times 2, which is 2 to the 6. It has 4 times 4 times 4, equals 4 to the 3rd. And it also has 8 times 8, which is 8 squared. And each one of these is all equal to 64. Now, I'm going to use this one because I see the 6 here, and I see a 6 in the denominator of the exponent. So, what that means is I'm going to set up my problem as 64. I'm going to write as 2 to the 6. So originally it's 64 to the 5/6. But taking this 2 to the 6, I'm going to do 2 to the 6 to the 5, 6. And when I do that, I end up, it's a power to a power, so I end up multiplying exponents. And I can cancel those 6's. And now I have 2 to the 5th. And if I look at my powerful numbers booklet, or if I do this on the calculator, I find out that this is 32. You will need to show work for this. And this is the kind of work that you would need to show. If you just typed this into a calculator and wrote down the answer as 32 and didn't show any work, you get 1 point for the correct answer, but you would miss any opportunity to get points for the work. 22, same thing. So if you don't have your powerful number booklet and you don't have the formula sheet, here's how you would do the problem. 81 is going to be equal to either 3 times 3 times 3 times 3, which is 3 to the 4th, or it could be equal to 9 times 9, which is 9 squared. Some students ask, well, how come I can't use 9 squared? How come I can only use 3 to the 4th? Let's first see 3 to the 4th. I would choose the 3 to the 4th one and not 9 squared because there's a 4 in this exponent and a 4 in that exponent. So if I set this up, I'm going to say that that original 81 to the 3/4 is now equal to 3 to the 4th raised to a 3/4. A power raised to a power is multiplying exponents, and that causes those to cancel, and I get 3 cubed, which is 27. I'm going to duplicate this page and solve this problem to you again with 9 squared. Just to show you what happens in case you're curious. If you're not curious, feel free to end the video early. Save yourself time. Get out of here. Enjoy life. Just kidding. Enjoy life. Alright, it's time for me to go to sleep. It's 11:30. I gotta go to bed. Alrighty. Okay. So, what if we use 9 squared? What if you're like, well, Mr. Lakin doesn't know what he's talking about. I'm going to use 2. So, let's take 81 to 3/4. And let's take 9 squared this time. Let's see what happens. So 9 squared to the 3/4 is the same thing as 9, a power raised to a power, multiply the exponents. So then you get 9 to the 2 times 3/4, which reduces 2. Now that's going to be 6/4. That's 9 to the 3/2. Well, 9 to the 3/2, I'm going to get a little bit stuck here. 9 to the 3/2, we could be a little bit crafty, I suppose. Let's take a look at 9s. If I go to a different page of the booklet, I have 9 is equal to 3 times 3, which is 3 squared. Oh, okay, that's perfect because I have a 2 in this exponent and 2 in that exponent. So I can then rewrite this problem as 9 to the 3/2 is equal to 3 squared to the 3/2. And I have a power to a power. So I multiply the exponents. The 2's cancel. And I'm left with 3 to the 3rd, which was the answer that I originally got, which is 27. Okay, if you took the time to watch all that, my point, choose the number that has the denominator that you started with, because if you don't, you make yourself more work. You'll still get the right answer, but this was definitely a shorter way because, again, the denominator in the original exponent and this exponent here cancel each other out, so you get to the answer right away. That's all, guys. Thanks for watching.